Okay. So we discussed about probability, the difference between, an event occurring versus an event not occurring. Right? If an event occurring has a probability of 0.2, probability of that event not occurring would be 1 minus 0.2 and you get 0.8. When you add probability of an event occurring plus probability of an event not occurring, when you look at the summation of that, you get overall 1. Then we looked at a concept of joint probability. If you have a word called as lottery in your email, it can either be spam or it can be ham. Ham means not spam. So joint probability is this intersection part. If there are two events which are independent of one another, there won't be any intersection. You will not find any intersection space. If you do not have any intersection, then this is a formula. Probability of A and B is equal to probability of A into probability of B. Okay. Okay. So probability of A is 5%. There's 5% probability that emails will have the word lottery. And there's 20% probability that emails will be spam. So all you do is multiply these two to get the overall probability values. However, if two events are dependent on one another, then the formula which is used slightly changes. You get this kind of a formula wherein probability of A given B is given as probability of B given A into probability of A by probability of B. Whatever is a numerator, put it there. Whatever is in denominator, put it here. And flip the order. That's it. That's one short way of remembering the rule. There we go. We have Bayesian rule. If we have multiple words, then how do I proceed further, or how do we proceed further with calculation? To understand this, we need to get into documents. Where did I put that? There is a new sheet that I created for this calculation purpose. Let me search. No, I'm surprised. What is this file? Maybe Excel is not. Can be. Just give me a minute. Okay. Just give me a minute while I try to pull it from my email. Okay. Found the file, so let's proceed. So we will be directly applying this formula. Likelihood, class prior or prior probability, data prior or marginal likelihood, posterior probability. Suppose you're working in a specific project, which includes, given that request, say you need to automatically assign that request to either routine request or audit. See, you have a two-class problem. Okay. The moment there is a request which is received, you need to classify whether that particular request will go to routine request or will it go to audit request. Automatically, we need to classify. So when you look at the historical data, say you had in total 481 requests. And in all those requests, when you looked at the words, keywords, you found that there were only 4 unique words. Okay, this is a toy example, a very small example. Say these are those 4 words. Only 4 unique words were there in total 481 requests. Those 4 unique words are listed down here. And out of 481 requests, 381 are related to routine requests and 100 are related to audit related requests. The word extend appeared in 250 places in routine requests. Out of 381, in 250 requests, the word extend was there. Means in another 131 entries, because if you add these two, you get 381. So in remaining 131 entries or requests, you did not have the word extend. Then run out was there in routine request. Out of 381, in 300, you had the word run out. In another 81, because total should be 381, you did not have the word run out. Invoice was there in 350 out of 381 requests. In another 31, invoice as a word did not exist. Then 30 out of 381, we had the word audit. 351 out of 381, we did not have the word audit. Then we have audit related requests. How many do we have? 100. Out of these 100, in 20, we had the word extend. In another 80, we did not have the word extend. So overall 100. Runout was there in 10 of 100. It wasn't there in 90. Invoice was there in 50 of the audit requests. In another 50, you did not have the word invoice. Audit was there in 80. And the word audit was not there in 20 out of 100 requests. Here, right? And you add them up. Overall, the word extend appeared in 270, did not appear in 211. Overall count when you add, it should be equivalent to 481. In that way, you have the count. Done. Now, going by this formula, probability of class given data is equal to probability of class into probability of data given class into divided by probability of data. The same formula, we will take that and put it here. Okay. Now we need to proceed further and do some calculations. You first of all, if you look at this formula, what is the probability of a class given word? Means, given that I have a word extend, what is the probability that it will belong to audit? Given that this word was available in one of the requests, okay, what is the probability that it belongs to audit? For that, this is like P of A by B. You flip it, make it extend given audit, multiplied by probability of A, which is numerator, divided by probability of B, which is denominator. Right? This is the basic. Here, you're calculating all of these probabilities. This is nothing but C3 divided by A3. Okay. So C3 is 250, A3 is 381. So 250 divided by 381 will give you the probability pertaining to routine request. Then here you say D3 divided by 381. You do that throughout. 300 divided by 381, 81 divided by 381, 350 divided by 381. And then here you're trying to get extend. What is the probability that the request belongs to audit, given that it has the word extend, right? For that, first of all, you see how many times this word extend appears given the audit request. Probability of extend given audit is this 0.2, 20 by 100. What is the probability that the request belongs to audit given that it does not have the word extend? 80 by 100. Okay, sorry, this one. What is the probability that you have the word, you do not have the word extend, given that it is audit request? Will be 80 by 100. What is the probability that you have the word run out, given that it is audit request? Is so much. What is the probability that you do not have the word run out, given that it is an audit request? Is so much. What is the probability that you have the word invoice, given that it is audit request? Is 50 by 100. What is the probability that you do not have the word invoice, given that it is audit request? Is this much. What is the probability that you have audit, the word audit, given that it is audit request? Is 80 by 100. What is the probability that you do not have the word audit, given that it is audit request? Is 0.1. Okay. Then we also need to calculate prior class probabilities. What do you mean by prior class probabilities? Prior probability is equal to probability of, for example, audit or routine request. A3, how many routine requests do you have out of overall requests? When you divide it, you get this. How many audit related requests do you have out of overall requests? You get so much. So all we are trying to do is, from this formula, in order to calculate the left-hand side, you need to know right-hand side values. So we're just trying to compute all of these right-hand side values. Now, let me do one simple calculation for you guys. Okay. Say you have a request which says, extend the runout. And spelling mistakes. Okay. Now, if you look at this first record, and if you want to classify this record to either routine request or audit request, this would be called as a two-class classification problem, because you have two classes, routine request or audit related request. You have two classes. So you need to assign this to either routine request, or you need to assign this to audit related request. Okay. So first, let us do it for audit related request. Okay. What is the probability that this belongs to audit, given that it has the word extend and it has the word run out and it does not have the word invoice? Okay. Because invoice is not there, right, in this, but in your training data you have invoice. Then in the training data you have audit, but do you have audit here? You don't have. So, and you don't have audit. The minus sign there is saying that not. What is the probability that this request belongs to audit, given that it has the word extend, it has the word run out, it does not have the word invoice, and does not have the word audit? Everything has to be considered. Okay. So what is the probability that a given request is audit, given that it has the word extend and it has the word run out and it does not have the word invoice and it does not have the word audit? So how do you write this? You split it basically. Okay. Probability of extend given audit into probability of run out given audit, because you have multiple words, into probability of not having the word invoice, given that it is audit related request, into probability of not having the word audit, given that it is audit related request, into probability of audit, divided by probability of denominator, which is probability of extend into probability of run out into probability of not having the word invoice into probability of not having the word audit. This is one formula. You also need to figure out what is the probability that this specific request, extend the run out, belongs to routine request class. I'll say routine request, given that it has the word extend and it has the word run out and it does not have the word invoice and it does not have the word audit. Sorry. How do you write it? Probability of extend given routine request into probability of run out given routine request into probability of not having the word invoice given routine request into probability of not having the word audit given routine request into probability of routine request divided by Denominator. What do you have in denominator? Probability of extend into probability of run out into probability of not having the word invoice into probability of not having the word audit. Okay. When you use all of those values and when you calculate, what do we get? Okay. All right. So let me also tell you that the denominator pertaining to both of these, here and here, denominator happens to be the same. Probability of extend into probability of run out into probability of not invoice into probability of not audit. These two are the same. Then when I compare these two get cancelled. On both sides, if you have the same values, they get cancelled out. Right? Whichever is different, you compare it. For example, if it is 10 by 2, and if you're trying to compare it by 12 by 2, you can cancel out these two, right? That is exactly what we are doing. These two, we are cancelling it out. Because at the end of the day, we need to compare these two. So only numerator comes into picture. Agree? Okay. Anyways, I think we can get back those values. And that is exactly what we are doing here. So if you look at C7, what is C7? Probability of having the word extend. What is extend given routine request? E7 will give you probability of having the word run out, given that it is routine request. What does H7 give you? H7, probability of the word invoice not appearing, given that it is routine request. Then what does J7 give you? Probability of audit not appearing, given that it is a routine request. So you multiply these four. When you multiply these four, okay, then these four are getting multiplied. Probability of extend given run out, routine request given run out, not having the word invoice, not having the word audit given run out. But what about this? We need to multiply that also. So that is C14. Where is C14? C14. This is probability of run out. Okay. Overall, how many probability of routine requests. How many routine requests do you have out of 481? 381. You multiply all these values, and when you multiply all those values, what do you get? You get this. Since the denominator will be gone, I'll just remove that. Denominator gets cancelled out when you try to do a comparison. Okay, so you get this form, or you get the answer for this. Okay, what is the probability that we're getting, or what is the likelihood that we're getting? 0.03. Next, if you want to do it for this probability of audit given all these things, that means given this request, what is the probability that it should be assigned to audit class? And same formula applies once again. If you were to look at this, you are trying to multiply C8. What is C8? Probability of extend given audit. Then E8 would be probability of run out given audit. H8 would be probability of invoice not appearing given audit request. J8 would be probability of audit not appearing given that it is audit request. Because in this request, invoice and audit are not there. So you're going with no, and you're looking at the values pertaining to no. Since extend and run out are appearing, you're going with yes. Done. So you have likelihood. Now, when I divide this likelihood, this by this, what do we get? You get approximately 73.7. Can be approximated to 74. 74 means there is 74% more chance that any request that you get would be assigned to routine request than audit related request. Okay, we say that this specific message is 74 times more likely to be assigned a routine request class than an audit related class. These are the kind of inferences that we can draw. But these are not probabilities. Probabilities means when you add them up, it should be equivalent to, is it equivalent to 1? No. Here, nowhere I told that we are calculating probability. This is what? Conditional probability. This is not probability. In order to get your conditional probability, formula is E4 divided by overall count would give you probability pertaining to routine request. Then if you look at this, it will be E15 divided by the overall. You get this. So by looking at this probability, to which request would you assign this to? Routine request, because probability of this getting assigned to routine request class is 0.98 and probability of this getting assigned to audit related request is 0.013. So ultimately you'll say that given this, it will be assigned to routine request. All with me until now? Wonderful. Now, let me take a new request. What is a new request? Say extend the runout checkout. Do we have the word extend? Wonderful, we have. Do we have the word runout? Yes. But we do not have the word invoice. We do not have the word audit. From the historical data, only 2 words are there, 2 words are not there. Fine. But there is a new word that is appearing. What do we do with this? Okay. But even before I proceed further, I think at this juncture, I can show you the formula when you have multiple words. It can be written like this. Okay. You have this, right? If I take a log, and you know what? Log of A into B is equal to log of A plus log of B. So it will be log of all these things plus log of this. But here what is happening? It's all multiplication. It's not addition, right? It's multiplication. If it is addition, I would have given summation symbol. But this is all multiplication, so I'll give you this symbol. This is what symbol? Addition. But within this, we have multiplication, so you give multiplication notation. So you say probability of the class plus log of probability of word given class. Look at this. Log of, when I use this as A and this as B, how will the formula look like? Log of A plus log of B when you take log. So this would be written as log of probability of the class plus log of all these. Probability of word given class, word given class. Agree? But here, since you are multiplying, you put a multiplication symbol. It's not summation. And that is exactly what is given here. Okay. Sorry, their summation was given because you need to look at various other things also. But then if you want me to write down the formula, let me write it. Probability of belonging to a class given the various words, word 1, word 2, so on and so forth, is given as 1 by z, and this 1 by z is called as a scaling factor. Okay, it's called a scaling factor. This scaling factor will convert the result into probabilities. It will convert the results that you get into probabilities. Into probability of class into multiplication of I equal to 1 until n, that is I equal to 1, 2, 3, all these words, into probability of word given class. Okay. When you substitute I equal to 1, it will become probability of word 1 given class. Into, when you substitute I equal to 2, probability of word 2 given class. Into, when you substitute I equal to 3, probability of word 3 given class, so on and so forth. Into the probability of the class. Okay, this is a formula. Let's stick to this formula. Now, the discussion that we are having here is, what if I have the word, additional word called checkout? Then how does it work out? Let's understand. It won't. Better I write it again. So probability of this specific request belonging to routine request. Let's write it. Probability of this belonging to routine request, given that it has the word extend and it has the word run out, and it does not have the word invoice, and it does not have the word audit. And there is another thing which is coming up. It has the word what? Checkout. It has the word checkout also. You have the word checkout also, right? It's a new word which was not even there in your training data set. Right? In training data, what are the words that you had? Extend, run out, invoice, and audit. In this training data, do you have the word checkout? No, we do not have. Now, how do you write the formula? Probability of extend given run out into probability of run out given routine request, extend given routine request into probability of not having the word invoice given routine request into probability of not having the word audit given routine request into probability of checkout given routine request. Denominator we are least bothered because that gets cancelled out. Because we also need to find out probability of audit given that you have the word extend, you have the word run out, you do not have the word invoice, and you do not have the word audit, and you have a new word called checkout. You write this as probability of extend given audit into probability of run out given audit into probability of not having the word invoice given audit into probability of not having the word audit given audit into probability of checkout given audit. For all these things, you'll have the probabilities into, of course, numerator, probability of routine request into probability of audit. Now, one second. Okay, anyways. Now, all these will have probabilities. What do you think will be the probability pertaining to this? The word checkout never appeared in your historical data. So what will be the probability of having the word checkout given routine request? 0. The word checkout was never appearing in your historical data. In audit, do you see the word checkout? So what is the probability of that appearing? 0. 0 multiplied by anything will become 0. So all the results will become 0, 0, 0 throughout. All the probabilities will become 0 throughout. To address this issue, there is something called as Laplace Estimator. Because you cannot expect each and every historical word or each and every new word rather to appear in the historical data. In the historical data, sometimes you might not have the words which might appear in your new data. If that is the case, what do? We have to resort to something called as Laplace Estimator. What this Laplace does is, it is simply going to add 1 to all the places. What do you mean by to all the places? Instead of saying that checkout did not appear, Laplace Estimator will add 1. Okay. The moment it adds 1, means it appeared one time. It appeared one time in audit related request. Getting there. Yes. Okay. What do you have now? Checkout. No, you have to answer. You tell me. You just apply your thought process and let me know. That way, you will also start thinking through, right? Okay. All I'm saying is add 1, 1, 1, 1. Okay. So you get 2 and 2, right? But then this is not how it adds. So when you add 1 and 1, 1 and 1, what happens is here also you increase. Okay. Or is my calculation wrong? Just give me a minute. Let me tell you. Hold on, just give me a minute. I'll tell you what it does. Ideally, it should okay. Okay, hold on. I'll not take these counts. So what it does is, if you add one here and here, here and here, you're also expected to balance out that, add one throughout. So this you make it as 251. Okay, and just a minute. Let me look at this table. Okay, fine, got it. Fine, let me explain. I'm just looking at those numbers to get correct explanation. Okay. So what it does is, since you're adding one to yes, here also you add one, here also you add one, here also you add one, and here also you add one. Okay. Since you're adding one, you add one throughout. When you add one throughout, 1, 2, 3, 4 places, you also need to increase this. This becomes 385. Okay, because these are places where you're adding 1, 1, 1, 1. Okay. When you add 1, 1, 1, 1 throughout, result as okay. When you add these, you're not getting 385, is it? Is that what you're saying? We have to add. We'll do it. So you added 1, 1, 1, 1 throughout. When you added 1, 1, 1 throughout, you have to add 4 numbers here. Okay, first one. Then if you are adding 1 here to check out, here also you need to add 1. 11, 51, and then this becomes 81. Okay, correct? So okay. So you add 1 throughout, right? So the logic here is, you add Laplace equal to 1, you add 1 to each of the numerator in likelihood function alone. Okay, in the likelihood function alone, you add 1 to each of the numerator. And then how many ones you are adding, those many ones you add and put it in the denominator. So total all ones and add it to the denominator. Okay. So in this formula, just to ensure that this doesn't become 0, what should I do? I have to put 1 divided by total number of audit requests. Here also you add 1, 1, you add 1, you add 1. So for extend probability of E given A, before I added all these ones, Okay, before I added all these ones, right? What were the values? Probability of extent given audit. Probability of extent given that it is audit would be what? 0.2. But it will be what? 20 divided by 100. So this would have been 20 by 100 into probability of routine request given audit would be, sorry, run out given audit would be 10 by 100. So into 10 by 100 into probability of not having the word invoice given audit. Not having the word invoice, no is here. Given audit is 100. So it will be 50 by 100. Into probability of not having the word audit given audit. Not having the word audit is 20, 20 by 100. 20 by. Into probability of checkout given audit would have been 0. Into probability of audit was probability of overall audit, sorry, here it is. It is 100 by 481. So into 100 by 481. Okay. Now, when you have new words which were not part of your training data, you would have got the results as 0. Okay. Now, in order to avoid that, what did we do? We discussed about Laplace. When you say Laplace equal to 1, what it ideally does is it will add 1 to each numerator in the likelihood and divide by the total number of all ones. So let's understand how that calculation happens. Laplace estimator equal to 1. By default, it is 1, but Laplace values can be changed also. So now it should ideally be you add 1 to all the numerators. So you will write the 21 by 100 into 11 by 100 into 51 by 100 into 20, not divided by 100, sorry. Anyways, I'll change that into, you put 1 by 100 into 100 by 480. So what you're doing is, instead of 0, you're putting 1 there. But how many ones are you adding? 1, 2, 3, 4, 5. 5 ones you're adding. So you ideally divide it not by 100, but 105. You won't touch this. Only to the likelihood functions, you add 1 to the numerators. And how many ever ones you are adding? Here you are adding 1, 1, 1, 1, 1. 5 ones you are adding. That is nothing but 5. So the denominator should contain 5 more. Originally it is 100. You put 105. Okay. This is how Laplace estimator works. The same goes with this also. Okay, fine. Now it's correct. The explanation is complete. That is how the calculation happens. And ultimately, you will get a probability pertaining to this also. Otherwise, probability would have been 0. And if I change this Laplace estimator to basically 2, instead of 1, if I add 2, what will happen? Let's see. 2, 2, 2, 2, and 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the denominator, you will have 110, 110, 110 everywhere. Either you add 1 or 2 or 3, doesn't matter, right? At the end of the day, they get cancelled out. So for simplicity's sake, they take 1. That's the default value. That is how your naive-Bayes algorithm works. This is how it works. Okay. I think we'll not have time to run the code, but anyways, a few more things. Okay. So denominator gets cancelled out when likelihood is calculated, hence you forget. And We use log, which is taken for under prevention, basically. Probability values will be less than 1. And when we keep multiplying those values, what will happen? If I multiply, probability values are less than 1. If I multiply 0.8 by 0.7, how much would you get? So this number will be smaller than these two. Again, probability values are smaller. So if you multiply this with another probability value, whatever be that value, you'll get again a number which will be smaller than these two. And eventually probability will be close to 0 if you have many words. To avoid that, we take log. The moment you take log, multiplication becomes addition. In the formula, we have written multiplication. Okay, but then the moment you take log, this multiplication will become addition. Okay. So naive-Bayes algorithm comes up with this kind of a frequency plot. The numbers, how many times it is appearing, etc. It will come up with a frequency table. KNN comes up with what? Distance matrix, calculates the distance. Decision tree comes up with rules. Naive-Bayes comes up with a frequency table. And you need to convert your data into categorical format. Only then you'll have categories. Here we have words, but otherwise you'll have categories. If you have numeric variables, numeric features, you need to convert them into categories. How do you convert numeric data into categorical data? What is the technique called as? No, dummies is to convert your categorical into numbers. What is the technique called as? Discretization. We have a technique called as discretization. Okay. I think we are good. With respect to naive-Bayes, all the aspects that I wanted to cover, I covered. Now to run that piece of code, we'll not have time today. We'll run it next week. The first thing that we'll do is we'll run that naive-Bayes thing. And okay. Questions, friends, please. Ask me if you have any questions. We'll spend next 5 minutes on Q&A. Grouping or binning is called as discretization. Exactly. If you have income, you create high income, low income. Yeah. Only for? Because when we take a log, right? Not sure whether I will have to write it down again or I'll have to write it down. So what was the formula that we have written? Probability of class given word 1, word 2. I'll take only 2 words for the simplicity. Is given as 1 by z. Z is the scaling factor. It is only used to convert the results into probabilities, into probability of the class into multiplication of all these words, right? Probabilities of the word given class. Agree? No, is y plus, okay. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Denominator we didn't bother because denominator was getting cancelled out. Because when we have looked at probability of routine request, given the word extend and given the word run out. I'll take only 2 words, friends. It'll be easy for me to explain quickly, right? So given that you have these 2 words, you need to assign it a specific class. Does it belong to audit or not? Now this is written as probability of extend given run out into probability of run out given, sorry, routine request, my bad. Extend given routine request into probability of run out given routine request. Divide into probability of routine request, which is probability of class, divided by probability of E into probability of extend. Clear? Okay. Here, what will be the formula? Probability of extend given audit into probability of run out given audit into probability of numerator, which is A, divided by probability of extend into probability of run out. When you compare these two have the same denominator, so they get cancelled out. This is what we spoke. Now this formula can be written in this way. 1 by Z is anyway scaling factor. Probability of class into this part. When you say I equal to 1, the first word comes into picture. First word given class into probability of second word given class. Second word given class. Okay. Even if you look at this, this is probability of class into this part, which is nothing but multiplication. When I substitute I equal to 1, you get word 1 given the class, which is audit here, into. When you say I equal to 2, because you have only 2 words here, word 2, which is run out, given class audit. Is this clear? Syncing with this formula, right? Okay. Now what I'm saying is, this has an issue of underflowing. What do you mean by underflow? Probabilities. When you keep multiplying probabilities, probability values will be less than 1. Probability values range from 0 to 1, okay? Maximum 1, minimum 0. So probability values lie in between this. So if I multiply 0.8 by 0.6, how much do I get? 0.48. So it'll be smaller than these two. When I again multiply it with another probability value, obviously it'll be less. So again, you get a value which is much smaller than these two. So eventually, if you have more words, probabilities will become 0. To avoid that underflow issue, what do? We take a log to this. This is A into B. When you take A into B, what will become? Log A plus log B. Log of this entire value. But then, if you have again A into B, when I take a log, what will it become? This is nothing but multiplication part, right? This is nothing but multiplication part, A into B, A into B. When I take a log, what will happen to the multiplication? It will become? Okay. That is why you're seeing addition. Okay. Any other questions, friends? Yeah, sure. All right, friends. Thank you so much. Next week, I'll be connecting from Hyderabad. And the week after that, let's see. I'll plan to visit one of the locations. Okay. Thank you all, friends. Bye.